Remember that number talks are short number routines. They last between 7 and 10 minutes. It's recommended that you do them 2 to 3 times a week, but I personally do them nearly every day in my classroom. You typically want to start them at the beginning of the year so you can establish that routine, and it helps to establish your positive classroom norms. However, if you haven't started them yet and you're in your classroom, it is not too late to start. Kids jump into it very quickly and they enjoy that time every day. Remember, number talks can be done whole group or small group, or some days I actually do both whole group and small group number talks. And we use those hand signals as a way of helping with engagement and ensuring that everyone is thinking, and to help me as a teacher know who to call on first, second, third. So we've already talked a bit about the roles of the teacher and the roles of the student. So remember, the teacher encourages students to share their strategies. They pose questions and facilitate the discussion. The teacher is the only one writing during number talks. They do all the recording, and perhaps it moves students towards a big idea. I personally believe that all number talk should be moving kids towards a big idea, because I feel like every bit of our math instruction needs to be deliberate and driven by our instructional goals. And so I feel like every number talk should be going somewhere. The role of the teacher is to explain, the role of the student is to explain their own problem-solving strategy. They also need to pose questions and listen to their peers to make sense of their strategies. And ultimately, they learn from their peers. And so I hope tonight in our number talk that you'll have that opportunity as well. This slide talks about something that we call the talk moves, and you'll be learning more about the talk moves next week as you prepare for leading your first number talk in week 5. I want to take an opportunity just to talk through these briefly with you so you knew what the talk moves were. So the first talk move is called revoicing, and you probably heard me say, after someone shares with me a strategy, that I say, so you're saying, or so you did this, right? Do I have that right? That's called revoicing, okay? Another strategy that we often use is called repeating. And so repeating is actually when you get another student to repeat a student's strategy, okay? So I might say, Kellyanne, can you say Kalia's strategy in your own words, okay? I typically use that repeating strategy to bring focus to a particular strategy that I want us to move towards. So I use that when I've got a learning goal and someone's getting there. I get someone to repeat that. Okay, that's a way of emphasizing it. Another is just asking, do you agree or disagree with Miranda? And then so kids can give a thumb up that they agree, thumbs down if they disagree, and then talk about why. Okay, this just gets kids talking. Another talk move that we use is called adding on. And you use this talk move when a child has shared their strategy, but perhaps it's a bit incomplete, or you want them to say more, or perhaps they're just a little stuck. You might call in another student and say, John, would you like to add on? Okay. And so that then allows John to just add words to what someone else said. A lot of times it ends up being revoiced in a more clear way. Okay. The next talk move is called waiting. And it's wait time, and you probably already do that. That's when you just say, take your time, we're going to wait, right? And it's really not talking, it's just waiting, but it gives kids time to think. The last talk move is called turn and talk, and it's also called like think, pair, share. I love this strategy in class, in a face-to-face class. I'll be honest, it's really hard to enact in a virtual number talk because you can't really turn to one person and talk. So sometimes I might have you share your thinking in the chat, but it's really hard to use this talk move virtually. But when you're in your classrooms during this number talk, you'll be able to use this turn and talk. And again, we use it to emphasize ideas. We also use it just to give kids that practice in articulating their thinking. It's especially powerful for our English language learners who need that rehearsal time in order to get their words in the right order and get their words out correctly to be able to share their thinking. So when you pair that student up with another student and they both share their thinking, it allows that ELL student to kind of borrow some words or maybe hear how someone else explained their strategy, and that can support them as well. So now we're going to get started with our number talk this evening. As we get started, I'll remind you that I am going to show you an image. I'm going to start with images tonight, and then I'm going to move to some equations. After I show you the image, when you have one strategy, you put up the one thumb. When you have two strategies, 2 fingers, 3 fingers, just to indicate that you have some ideas. And then I will be calling on you to share your thinking, okay? This number talk, by the way, builds on the number talk we did last week, which was focused on using the distributive property, okay? So here we go. All right. So right now you shouldn't see anything yet. Ooh, here is the first image. You can't see it very well. Let me see if I turn off the light. Ooh, that's actually better. All right, so the question is, how many are there and how do you know? So take a moment to figure out how many are there and how do you know? All right, would someone please share with me your thinking? Who would be willing to share their thinking?
I multiplied the top row by the top columns by the rows.
You multiplied the top times the bottom. Tell me more about that. First of all, say your name. I'm sorry, I can't read names right now.
It's Allie.
Allie, okay.
I multiplied the top times the side, so like 8 times 3.
So you notice the top was 8.
Yes.
And the side was 3.
3.
And how did you figure that out, Allie?
1, 2, 3, 4, 5, 6, 7, 8.
Okay, so there's 8 up here. But how did you know what is 8 times 3? How did you figure that out?
Oh, I don't know. I just knew.
You just knew. That's okay, Allie. That's called a known fact. You just knew that 8 times 3 was 24. That's absolutely fine that you just knew, okay? I wasn't trying to trick you up, okay? Figured out how many in a different way, okay? So this is when I challenge kids, even if you thought about it 3 times 8 as well, could you come up with a different way? Like, how else could somebody see this? Who would be willing to share their thinking? Carla, are you ready?
Yes, ma'am.
Tell us about it.
I took the shaded amount, which was 369.
Okay.
And then
369. Okay.
And then I took the unshaded amount, which was 5, 10, 15.
5, 10, 15. Okay.
I knew I had 15, and then I added 10 and took away 1 to get 24.
Oh, so let's say that one more time. Let me repeat that. So you did 15.
15 plus 10.
Now, where did you get that 10 from, Carla?
25, because it's easier sometimes to add 10. But I know I had 9, so I knew I had to take away 1.
I see. So instead of adding 9, you just added 10 because that makes math easy in your head. So that gave you 25.
And then
then you had to take 1 away. Cool thinking, Carla. Very cool. Who else has a strategy that they would like to share?
I kind of followed, I'm sorry, this is Kimberly.
Okay.
I followed similar. I saw the die face with kind of die face. I knew that the 3 by 3 block was 9. And
Can I
saw
stop right there? Kimberly,
sorry.
Let me ask you, first of all, I spelled your name wrong.
Sure.
No, sorry. Okay. So you said you knew that this was a 3 by 3. So by 3 by 3, you meant 3 rows and 3 columns?
Columns, yes.
Okay, go ahead.
And I know that that means there's 9 in that set.
Okay. All right. Now what?
And that there were 2 of those and then 2/3 of one more. So I did 9 times 2 is 18 and 2/3 of that is 6 and 18 and 6 is 24.
So it sounds like you were looking for another group of 9 and you kind of imagined another group of 9 right here, like built onto it. Okay. And so that was 9 more. And then you said this was 2/3.
Right.
Okay. Which was 6 more. All right. And then you added all those up, and what'd you get?
24.
You got 24. Interesting, just like Allie and Carla. Did anyone do it a different way? An even different way?
I just counted by threes.
Who is that?
Miranda.
Miranda just counted by threes. So Miranda, can you show me how you counted, or tell me how you counted?
I knew there was 3 in each row, so I just counted by threes across. Like
So
3,
count
6,
for
9,
me.
3, 6, 9, 12, 15, 18, 24, or 21 and 24. Excuse me.
21 and 24. All right, that works too. And you got 24 as well. Did anyone do it a different way?
I did.
I did the, oh, sorry, go ahead.
Go ahead.
It's Kellyanne. I did the 5, 10, 15. So the white ones first.
So you did the white ones first. Okay.
And
So
I noticed.
did you count them 5, 10, 15, or did you notice it was a 5 by 3? How'd you think about that, Kelly?
No, I counted by row. I did 5, 10, 15.
Oh, I see. 5, 10, 15. Okay.
So I knew I had the 15 there, and I could see the 9. So I did.
Oh,
I
you
did.
just saw it.
Yeah, I just saw the 9, and I did the 9. I'm sorry, 10 and 15 minus 1 as well.
10 and 15 is 25. And then you subtracted 1, and that gave you 24. So you thought about like Carla.
Yes.
Awesome. Now, I noticed that Allie just knew that 8 times 3 was 24. Okay. But sometimes we might not know what 8 times 3 is. So looking at this picture, I wonder if you could decompose this image into 2 smaller parts that would make multiplication easier. So if I didn't know what 8 times 3 was, how could I break that apart into easier products, like smaller rectangles? Anyone want to give that a try and see what you think you can do with it?
3 times 3.
Okay, who is this speaking?
McKinley.
Say that one more time.
M-A-C-K.
Thank you.
Yes, ma'am.
Okay, I gotcha. All right, so you were saying a 3 by 3. Tell me what you mean by that.
Well, that's 9 because there's 3 in the top and then 3 on the side.
Okay, so you knew that 3 times 3 is 9. Okay.
And then there's still 3 rows, but there's 5 columns.
Okay.
Then that would be 3 times 5.
5 times 3 or 3 times 5 is
15.
What is it? 15. Okay. And when I add those together, I get
24.
24. So I want you to take a second and I want you to look at Allie's and McKinley's at the same time. Let me see if I can fold my paper to bring those out for you. When you look at these, you can see that their thinking was very similar, except what did McKinley do instead of multiplying by 8? John, what did she do instead of multiplying by 8? What did McKinley do?
She broke the 8 into the 5 and the 3.
Absolutely. She broke the 8 into 5 and 3.
And I thought of it a different way. If you did 4 by 3 and 4 by 3.
Oh, so you thought about it. Hold on, John. Let me get another.
So break it down to like 2 groups, 2 groups, 2 groups. And
So John was saying that instead of breaking it down by the 5 and the 3, that he took this and kind of cut it in half.
Uh-huh.
And did it by a 3 by 4 and a 3 by 4. And that worked out too, didn't it, John?
Mm-hmm.
Because 3 times 4 is what, John?
12.
12. And 12 and 12 is
24.
So both Mac's strategy and John's strategy are what mathematicians call the distributive property. And basically, the distributive property tells us that we can break apart numbers into friendlier pieces. So if I don't know if I'm not like Allie and just knew 8 times 3, I could decompose that 8 into smaller numbers to make the multiplication easier. So now I want us to apply that to just solving some equations. Are you ready to solve some equations? Here's the first one. The first one's going to be 6 times 7, okay? So if you will take some time to think about 6 times 7 and think about how you could solve that in multiple ways, hopefully using that distributive property we just talked about. All right. Jada, will you share with us your thinking?
So I just counted by 6, like 6. So 6, 12, 18, 24, 30, and then 36.
Okay.
And then
So
40.
And then 42. Excellent.
Yeah, 46,
So,
sorry.
So Jada used a counting strategy. Y'all were reading about that this week, right? And counting strategies are typically connected with skip counting, okay? Awesome counting strategy there, Jada. Very good. Now, I also wanted to bring out for my pre-service teachers to step outside of the number talk for just a second. I noticed that Jada wasn't really just like rattling them off like 6, 12, 18, 24, because nobody really knows their sixes, right? But what she did was in her head, she was very quickly getting 6 more. That's okay. That's still considered a counting strategy because she skipped counting, okay? John, I see your thumb up. You look like you're ready to share. Tell me how you thought about it. John, we can't hear you. You're muted, friend.
6 times 5 is 30.
Where'd you get the 5?
I'm breaking the 7
Okay.
into 5 and 2.
Into 5 and 2. All right, keep going now.
So 6 times 5 is 30.
Okay.
And then 6 times 2 is 12.
Okay.
And then add the 30 and the 12 together, and it's 42.
42. And so, John, you got the same solution as Jada, but you use that distributive property. Let's see. Lauren, will you share this strategy in your own words? Tell me about what John did.
He split the 7 up into the 5 and 2 because 5 plus 2 is 7. And so then he did 6 times 5 and got 30, and then did 6 times 2 and got 12, and then added 30 and 12 and got 42.
John, thumbs up if you agree that that's what you did. Awesome, awesome. Let's see, who haven't I heard from? Holly, will you share with us your thinking?
Let me unmute. Okay, so for me, in multiplication, it was always easier to multiply the same number or a number by itself, like 6 times 6 or 5 times 5.
Okay, so that's called using a square. Okay, so tell us how you used a square, Holly.
So I knew 6 times 6 was 36. Okay. For some reason, even when I was young, I remembered those numbers before anything. 6 times 6 is 36, and I just added another 6.
So why did you add one more 6?
Because I knew it was 6 times 7.
Okay, so it was like
6.
I see. So one more group of 6, and so that made 42.
Yes.
So just like Holly said that as a kid she memorized those doubles, or they're actually called squares, right? The 6 times 6, 7 times 7, 8 times 8 first for some reason. So the truth is that's very true for kids. we don't really know the science of why, but you're absolutely right. You're 100% on target with that, okay? So Holly used a square number. I want us to go on to one more problem tonight. I know that many of you still have awesome strategies. And y'all, what I would have you do right now in a classroom is turn and talk and tell someone, because some of you are still just you're so excited to share. But for the sake of time, for our number talk, I'm going to go ahead and move on. If I was in my classroom, I'd take that time, but I'm trying to push us in a very small time frame. So let's go to 8 times 9. Okay. So in your head, you're figuring out, how do I know what 8 times 9 is? Okay. I'm going to give you some time to think about it. I'm going to have Sarah, can you share first?
Sure. So I know, kind of like Holly was just saying, that making a square. So I know that 8 times 8 is 64.
Okay.
And then if I add 8 more, that will give me 72.
So tell me, where did you get this 8 from? When you said 8 times 8, where do those 8s come from, Sarah?
The 1 8 comes straight from the problem, and the second 8 is 1 less than the 9.
1 less than the 9. So it's kind of like you broke apart that 9 into 8, and then you needed one more group of 8. Yes. Cool strategy, Sarah. Cool strategy. Taylor, will you share with us your strategy?
Yes, ma'am. I broke the 8 apart into 4 and 4.
Okay, you broke the 8 into 4 and 4. So how'd you think about that?
4 times 9 and 4 times 9. So you're multiplying the same thing.
Ooh, nice. And what is 4 times 9?
36.
36. And 36 and 36 is?
72.
72. Anyone else have a super fancy way that they want to share? You can just unmute and tell us your amazing idea.
I did 8 times 10.
Okay, so instead of doing 8 times 9, you did 8 times 10. This is Kellyanne, right?
Yeah.
Okay, you did 8 times 10.
Which is 80.
Which is 80.
And then I took 8 away from the 80.
Okay. And that left you with?
72.
Notice I won't tell you. You have to tell me, right? In a number talk, I don't try not to make assumptions. I make you tell me. So Kellyanne, tell me, where did you get this 10 from? I don't see a 10.
I instead of making it a square,
okay.
I always work in 10s whenever possible.
All right.
So I went up with I added one more group of 8.
I see. That's one group of 8. Okay.
And then one more group of 8 made it 90, which was easy to work with. And then I knew that I had one group too many, so I had to take another 8 away.
So 8 times 10 was, you just
80.
said 90, but you meant 80. Okay, 80.
I'm sorry.
You're fine. You're fine. And then you had to take one more group away, and that left you with 72.
Right. I gave one group there, and I had to take it back.
And you had to take it back. Y'all are absolutely amazing. Now, here's why you're amazing. The next thing I wanted to talk to you about today, after you've done a great job of using this distributive property, because you've all been able to break apart these numbers in some way to make multiplying even easier. So you were all able to utilize that distributive property that we've been talking about. So the cool thing for me as your instructor is the next thing I wanted us to spend time talking about tonight actually has to do with these exact strategies that you use. And I think within our number talk, we used almost all of the strategies that I wanted us to review tonight. So if you haven't seen it yet, sometime soon you're going to see this chart of the reasoning strategies that kids use to learn their facts. Now, if you're like me, when you were a kid, your teachers had you learn your 1s and then your 2s and your 3s and your 4s, and you did them in order. So research says, meh, not the best plan, okay? Instead, kids should focus on learning some foundational facts, okay? And so if you're looking at this chart, the foundational facts are the 2s, the 10s, and the 5s are like the first foundational facts. Anyone want to guess why 2s, 10s, and 5s? Why would we want those first?
They're the easiest.
They're the easiest. You're absolutely right. Like, so you learn your 2s, your 5s, and your 10s. Also, kids have lots of experiences with skip counting by 2s, 10s, and 5s, okay? So we learn those first. And then we start learning our 1s, which is called the identity property. I'm sure you already knew that. And then we learn our 0s, which is called the 0 property. And then, just like Holly mentioned, we also learn our squares. We don't know why, but kids are just kind of attracted to the square numbers, like 3 times 3 and 9 times 9. So the idea is, after they learn these foundational facts, then they can use these facts to figure out all the facts they don't know, okay? For example, if kids come across something times 4, they can basically just double the 2, right? And that's going to tell them the 4s. Likewise with 6, they know if they already they could use their 3s and double them, or they could do the 2s 3 times to get to the 6s, okay? Another strategy that kids use is adding a group, okay? This is a strategy, a lot of you actually used adding a group with squares, where you found the closest square number and then you would add like 8 more. Or if it was multiplying times 9, you'd add another 9, okay? And so those are particularly great when you're learning your 3s and your 6s. Because if I know my 2s, I add one more group, now I have my 3s. So you see, I can just take the 2s that I know and figure out my 3s. I can do the same thing with my 6s. If I know that 3 times 5 is 15, well, 3 times 6 is just going to be another group of 3, okay? One more group. You also were able to use this subtracting a group idea. I believe Kellyanne did that one at the end, where remember, instead of multiplying 8 times 9, she did 8 times 10, and then she subtracted a group, okay? And y'all, that is the best strategy to teach kids for 9s. Do your 10, take away a group, okay? Same thing with 4s. They can do their 5s and take away a group, okay? I would say, notice that all of these say break apart, 3s, 4s, 6s, 7s, 8, all the derived fact strategies all are down here in break apart. Well, y'all, that's really because all of these derived fact strategies are really using that distributive property, right? We're going to break apart numbers into friendly pieces that we can work well with. So really, all of these strategies are based on that idea of using the distributive property. So I hope that that little quick mini lesson supports you as you move forward this week and next week into analyzing students' problem-solving strategies and thinking about how to support your own students and your own future students in learning those facts. So we start with the foundational facts, and then we move on to support them in learning to derive facts. And y'all, the best place to learn those derived facts is to use the number talks like we did today, and even do like the 2 colors or the 2 shadings that really bring out that decomposition. Oh, I hope it's there. There it is. The other thing I wanted to share with you is this idea of anchor charts. And notice it says student created anchor charts, not teacher created anchor charts. So what we often do is, as we come together, and like today we worked on the distributive property, we would actually take these examples where you use the distributive property, and I could paste them up onto this anchor chart, right? And we could work together as a class to come up with a nice definition, a working definition. But then we'd have all of these examples that had meaning to us as a math family. So I encourage you, as you're making anchor charts, not to just buy one on Teachers Pay Teachers and put it up on the wall. But if you want one that really has meaning, you're going to attach it to the things you're doing in your classroom and kind of use it as a way of displaying their ideas. So that way everyone will say, oh yeah, this is like Sarah's strategy, or this is like what Taylor did. Okay, so we want them to connect that. So make those anchor charts student created, student involved, not just something that you buy on Teachers Pay Teachers, which y'all, I love too, but not always the best stuff. So hold on one second while I stop our recording.